Lesson 3-4, we will be discussing exponential and logarithmic equations. In video 3.4.2, our learning target will be for students to be able to solve logarithmic equations. In example 2, part A, we are asked to solve logarithmic equations using one-to-one property. In part A, we're asked to solve 2 times the natural log of x, which is equal to 18, and round our answer to the nearest hundredth. Now, if I take 2 times the natural log, which is ln, of x, is equal to 18. The first step in solving any logarithmic equation is to get the logarithm by itself. So in other words, I want to get the natural log of x right here, all by itself on one side of the equation. So the first thing I will do is to eliminate the 2 in front of the natural log x, and since I'm multiplying by 2 out in front, I will divide both sides of the equation by 2. So if I divide both sides by 2, the 2's cancel on the left side, I'm left with natural log of x equals 9. And at this point, when you have a logarithm by itself, you can rewrite that exponentially as e to the 9th power is equal to x. Since natural log is base e, you would take the base raised to the power, because after all, a logarithm is just an exponent. And that is equal to your input, which is x, which is what we're looking for. So at this point, I need to evaluate e to the 9th, and I can type that in on my calculator, and it says to round to the nearest hundredth. So if I type in e to the 9th power, that gives me 8,103.08. And that is my final answer. In part B of example 2, we're asked to solve the logarithmic equation 7 minus 3 times the logarithm of 10x equals 13 and round to the nearest hundredth. Now, the first step in solving any logarithmic equation is to get the logarithm by itself. Okay, and if I get the logarithm by itself, log of 10x is, I need to eliminate everything except for the log of 10x on the left side of the equation. Okay, so the first step here is I'm multiplying by -3 in front of that logarithm. So before I get rid of that -3 in front of the logarithm, I am going to subtract 7 from both sides to start getting the logarithm by itself. Here I get -3 times log of 10x equals 6. Now I can eliminate the -3 out in front of my logarithm. So I'm going to divide both sides by -3. That gives me log of 10x equals -2. And at this point, since the logarithm is by itself, I can rewrite this problem exponentially. Well, since I don't have a base on my logarithm, I can assume that it's base 10. It's a common logarithm. So I'm going to say 10 to the -2 is equal to 10x. My base right here, since I don't have a little subscript number, I can assume my base is 10. Well, 10 to the -2 power, I'm going to go up here. I'm running out of room at the bottom. 10 to the -2 power is 1 over 10 squared, which is 1/100th. Right? So 10 to the -2 is 1 over 10 squared, and 10 squared is 100. And that's equal to 10x. And then I can divide both sides by 10, because 10 and x are being multiplied by one another. So I can say that 1/100th divided by 10 is the same as 1 over 100 times 1 over 10, which gives me 1 over 1,000. That should be my final answer. Now, I could round my answer to the nearest hundredth, which 1/1000th is 0.001, or I can leave my answer in fraction form. In example 2, part C, we're asked to solve the logarithmic equation log base 5 of x to the 4th equals 20. Now there's a couple ways that I can go about doing this, solving this problem. We want to find x or solve for x, but here we have log base 5 of x to the 4th equals 20. Now our first step in solving any logarithmic equation is to get the logarithm by itself. Well, in this problem, we already have the logarithm by itself. The log is by itself on one side of the equation. So my next step would be then to rewrite this problem in exponential form. Well, in this case, I have 5 to the 20th power is equal to x to the 4th. This expression, or this equation right here, is the exponential form of this logarithmic equation. Now, 5 to the 20th is a really large number. I could type that in my calculator and write out this really large number, probably in scientific notation. So I'm going to leave that number written as 5 to the 20th. And to continue solving for x, to get rid of the 4th power, I can either do one of two things. Either I can raise both sides to the 1/4 power, which is the same as the 4th root. So I can either raise both sides to the 1/4 power or take the 4th root of both sides. The 4 and the 1/4, when you multiply them together, because you're raising a power to a power, 1/4 of 4 is 1. So x to the 1st is equal to x. Over on this side, 20 times 1/4 is 5. So my answer ends up being 5 to the 5th power. Now I could type that into my calculator, 5 to the 5th power, and write out my answer, or I could just leave my answer as 5 to the 5th. Now, I could have gone about solving this problem a different way. So on the next slide, I'm going to show you an alternate method to solving this problem, and I end up with the same answer. In the previous problem, we solved log base 5 of x to the 4th equals 20. I want to show you an alternate method to solving this problem. The first step would be to apply the power property of logarithms. So we know that when you have a power or exponent on your input of a logarithm, that power can be brought out in front and multiplied out in front of that logarithm. So we could rewrite the left side as 4 times log base 5 of x equals 20. And then we're going to go ahead and divide both sides by 4. If we divide both sides by 4, we get log base 5 of x equals 5. And now we have our logarithm by itself. So since we have a logarithm by itself on one side of the equation, we can rewrite this problem exponentially as this is our base, so 5. Our logarithm or exponent is 5, and that's equal to our input, which is x. So our solution is x equals 5 to the 5th, which is the same result we had on the last slide. In example 2 guided practice, you're asked to solve 2 times log base 2 of x cubed equals 18. What I would like you to do is to solve this problem. Choose your answer, either A, B, C, or D. The correct answer is there. And I would like you to submit your answer when you are complete.